Level 2 physics, electricity, let's tackle this 2021 question. The electric field lines between two parallel plates are shown. Clearly label the positive plate on the diagram. Let's do it. So this is worth an achieved. And so I've just copied and pasted that diagram down here. And I want you to pause and think about what plate's positive and what plate's negative. Assuming that you've done that, okay, always remember that when you look at the field line direction, that gives you a clue on what's positive and what's negative, because if something is going away or pointing away from something, you know that that's going to be the positive plate. And that's confirmed in the answer. The top plate is positive because the field lines always point away from positive charges and point towards the negative charges. And so this is how it's done. You might want to label it, okay? You might want to label it positive and negative. I'll do that right now. And negative. And that is an easy achieved. Next question. Describe, let me get my pointer, whoops. Describe the field between the plates and explain how the diagram shows this. Okay, so part B is asking you, why is it drawn like this? Okay, as you can see, the field lines are evenly spaced out, and they also meet the plate at a 90-degree angle, okay? And so, as a result of this, we can say that this electric field is uniformly charged. And that's worth a merit. The electric field between the plates is uniform. This is shown by the field lines being parallel and evenly spaced. Next question, part C. An experiment is carried out on the surface of Earth where gravity is 9.8 meters per second, where a charged droplet of this mass is held stationary between different set of parallel plates. The voltage across the plates is 240 and the distance is 2 centimeters. Add labelled arrows to show the two forces acting on the stationary droplet. And it's able to stay stationary because it's got a pull upwards, which is equal and opposite to the downwards pull. Okay, so if we were to draw what this looks like, this essentially is what it would look like. We've got an upwards force vector, which is labelled electrostatic force, because the electrostatic force occurs between two oppositely charged objects, okay? And so this particle must be a positively charged droplet because it's being attracted to a negatively charged plate due to an electrostatic force. And so that is what is pulling it up. On the contrary, we've got a downwards force, and that force is due to gravity, Earth's gravity, which is pulling this droplet down. And so this droplet's able to stay stationary because the upwards electrostatic force is equal and opposite to the downward force of gravity. And those are the two labelled vectors showing how this drop is able to stay stationary. Okay, next question. Calculate the number of elementary charges on the stationary droplet. You should start by calculating the weight of the droplet using this equation here. The charge of a single charge, okay, is this positive value here in coulombs. All right, so we want to figure out on this droplet, we know that it's positively charged, but we want to figure out how many positive charges does this oil droplet hold, okay? And we want a numerical value for that. So let's go ahead and do that by first working out the force due to gravity, because that's what the question has asked us to do. And so, using F equals ma, which is the same as this equation here, just written slightly differently, we've got the force, which equals the mass of the droplet, times 9.8, which is this acceleration caused by gravity, okay? Timesing that together, we get a force. The downward force on the droplet is this value here, okay? So, what is the goal? The goal is to work out the number of charges on the oil droplet. How many, let me just draw it with a different tool. How many positive charges does this oil droplet have on it? Okay, and so that is the goal. How are we going to do that? Well, there's an equation that your formula sheet actually does not give you, but it's worth remembering it, especially for an instance like this. So let me tell you, the equation that you need to use is this equation right over here. Q, which is the net charge, okay, equals N, which is the number of charge, times Q, which is an elementary charge, the charge on a single particle, a single charge, okay? And so you're given this in your formula sheet, or the question, that's that lowercase q, okay? It's the single charge. And so using this, we can rearrange it to find N, okay? And then we'll finish our goal. But there's a few things that we need to do in order to be able to use this equation, because we don't have all the values. We have the little lowercase q, I just showed it to you, but we don't have the net charge of the oil droplet. We don't know what it is. We know what one of these charges is, okay, which is Q, represented by little q, but we don't know the overall charge. And when we figure out what the overall charge is, we can rearrange to find the number of charge. So how am I going to find the net charge? What is another equation that I can use? Oh, that's just going through the steps of rearranging. Another equation that I can use is F equals EQ. And I know this is representing a little lowercase q, but this can also be used as the net charge, okay? So we can always consider this as a capital Q, the net charge, okay? So we've got force, okay, and we've got electric field strength, and we can rearrange to find this Q, which essentially is the net charge, capital Q, okay? But hang on, do we have force? Yes, we do, because we know it's equal and opposite to the downward force which we just worked out. So we can plug this force into this value and rearrange to find this Q, okay? Our third step is to be able to find out what the electric field strength is using this equation. So I understand that this is a lot to take in right now, okay? So I've written a summary on what to do, and this is what physics is all about. You kind of start off with the thing that you want to find, and then you have to go down a rabbit hole to see if you can find out the values that you need in order to find out what you originally want to find out, okay? So in summary, this is what we need to find: the number of charges on this oil droplet. In order to do that, we need to find the net charge, which can be used from this equation here. And in order to use this equation, we have to find the electric field strength using this equation over here. What I will add is F equals ma, and we can substitute in what we worked out for F into this equation. Alright, time to execute this plan. So we're starting off with, we're working backwards, so we're starting off with this equation over here, okay? So we've got electric field strength equals V over D, and so we know that the voltage supplied is 240. the distance between the plates is 0.02 meters. I've converted centimeters to meters by dividing by 100. And that gives me an electric field strength of this value. So now that I have electric field strength, what's next in my plan? I could sub it into this equation and rearrange it to find Q. So let's do it. I've got my F value, my force, which is plugged in from what we worked out previously, okay? Because the force downwards due to gravity is the same as the force upwards, which is electrostatic force, equals the electric field strength, which we just worked out from the previous step, and I've plugged it in, times Q. Now I want to figure out and rearrange for Q, but currently it's tagged onto a times 12,000. So to get rid of times 12,000, I divide by 12,000, and it cancels it out. So what I do to one side of the equal sign, I do to the other, and I'm left with Q equals this value here, essentially this side of the equal sign. I've just swapped it around. Plug that into your calculator and you should get Q, which is the net charge, essentially capital Q, is this value here. Now we're one step closer. Now what I can do is I can take my initial equation, rearrange it to find N, plug in my values, which is my Q, my net charge figured out from my previous equation, plugged in up top for big Q, and then my little q, which is the charge of one single charge, is this value here, and I get this value here. So this is the number, this is how many positive charges are on that single oil drop, which is a lot. But that's how you get to the end of the question. Is there anything else? Nope, besides the 2020 question, which I'll see you in the next tutorial for, or in class for. Alright team, hope that was helpful. Let me know if you have any questions, and see you later.